Ukmt IMC 2021. Today again I will start from number 11. If you have any questions from number 1 to number 10, please feel free to make any comment on this video. Let's go to number 11. The line equation 2x plus 3. Let me draw the line, like sketch the line roughly. So 2x plus 3, as we know, this has the positive slope and it has the y-intercept 3. So I'll just draw the line like this. And this one reflected in the y-axis. So after reflection, the new line looks like this. So it has same x-intercept but different y-intercept. So this was 3, but this was negative 3. You know, we can see the ratio of run and rise, like a rise over run. Here, we can say, actually run is the same, rise amount is the same, but opposite. So this has slope 2, and this may have slope negative 2. So we can tell it has opposite slope and opposite y-intercept. So this is the one. Andrew calculates 40% of 50%. Okay. Okay. So Andrew calculates 40% of 50% of x is equal to 20 of 30% of y. Okay. So 50% of x is half of x, and 40%, and 40 over 100 equal to 30% of y, 130 y times 20%, like this. So which of the following is true? So let me do this also 50 over 100 to make all cancel. And 0, 0, 0, 0, 2, and 2. Then 10x equals 3y. Therefore, y equals 10x over 3. And then remainder, divide by 9. You know, any number of the multiple of 9 is the sum of a whole digit is divided by 9. So for example, this one, 1, 2, 3, 4, which is 10. And 5, it cannot be multiple of 9. So for example, 1, 2, 3, 3, 0, 9. So this is the, yeah, this is multiple of 9. So this one, let me write plus 6, for example. So this is already multiple of 9 plus 6. And this also 5, 4, 3, 2. Let's say this is already 14. Doesn't make sense. 8, 12. We need another 6. Maybe 1, 5. For example. Then this one is 10, 18. So this was multiple. So when we expanded this, that idea is we make the FOIL from here to here. This multiply between two multiple of 9s, always multiple of 9s. And like this, also multiple of 9s. This one, multiple of 9. So those doesn't affect for the remainder. Remainder comes from here. So here, so we have all 1, 2, 3, 3, 9 times 5, 4, 3, 1, 5. We don't need to consider this. 6 times 1, 2, 3, 3, 9 plus 6 times 5, 4, 3, 1, 5 plus 36. But 36 also already multiple of 9. So actually these whole numbers, the sum of multiple of 9 goes to multiple of 9. So let's say 81 plus 18 comes, we can factorize with 9 like this. So this whole number is multiple of 9. So now this is all multiple of 9. So remainder is 0. So number 14 is the percentage of the shaded area. And this one, for example, if we set it here, just x, the one side, then this could be 2x. And all here, from here to here, 4x, and we divide by 3, so this is 4x over 3. So now we can calculate the whole area. X squared, we have 4. And 2x squared, we have 2. And 4x over 3 squared, we have 1, 2, 3, 4, 5, 6, 7, 8. This one can be, so 4x over 3, 1, 2, 3, 4, 5, times 5 squared. This is the larger area, nk. So which percent of this area will be to the left side? So 4x squared and 8 and 16, 9 times 8, 128. X squared equals k. So let me multiply all there 9. So here 108 236 equals 400k. So 400 divided by 4, 5, 9, 100. So 59%. 15. Patrick driver from P to Q. Average speed 40 mph. Come back 45 mph. 2 minutes less. But mph is miles per hour. So this is the unit with hour, but this is minutes. So 2 minutes is 2 over 60 hours. So if it takes t hours when we go from P to Q, it must be take t minus 2 over 60 hours when we come back. And we know another hint from P to Q, the distance is same from P to Q and from Q to P. So already we know that the relation between these three parameters, distance and speed and time. So now we have constant distance. So the speed and time, when we make them together, like multiply, then it should be same. So 40 times t equals 45 times t minus 1 over 30. 8, 9. 80 equals 90 minus 9 over 30. So t equals 9 over 30 equals 18 over 60. So this is the time taken from P to Q. So we can find the distance as it asks about the distance. So 40 times 18 over 60, 12. And let's go for the next one. Semicircle drawn this way. It has, on each side, it has all same semicircles. So for example, this and this actually is full circle. This and this also, when we combine them together, is full circle. So we want to, square has a side length of 2 pi. So 2 pi times 2 pi this is a square plus the radius is pi. So pi r squared, but we have all 2 squares, so half, and we have a 4 semicircle. So 4 pi squared plus 2 pi cube. So we factorize them with 2 pi squared, then 2 plus pi. So, and the next one, rectangle PQRS, length 2, side QR of length 4. Let's draw any rectangle PQR PQRS. So from P to Q to R 4. T and U lie inside the rectangle PQT to equilateral triangle, and RST also equilateral triangle. RSU. So yeah, I thought it was a little bit strange. So this is not same. So T and U. What is the area of quadrilateral QRUT? Okay. So this is, because it asks us about the area, we can find the area of rectangle and subtract the 2 equilateral triangle and divide by 2. Then that's the answer. So rectangle 4 times 2 minus for the right angle triangle. There is the formula for the area, square root of 3 over 4 a squared. A is the side length. So here square root of 3 over 4. 4. 8 minus square root of 3. But we want to know over 2. Because we want to know only half of that. So 4. I made some. So we have 2 equilateral triangle. So here 4 minus the square root of 3. Number 18, closest to the size of 1. Anyway, this is 95, and this is 960. This is 955. So anyway, this and this cannot be the answer. And from here 0.960 1.04004040, something like this. So this is also not the answer. So among 2, like between 2, this has the distance from 0, like 0.039 something. But this one has the distance 0.04 something. So this is closest. Number 19, overlapping rectangle P and Q. 1/4 of the total area of the figure. P and Q. Okay. So this is the area P and Q. So PQ equals. Q squared. So overlapping rectangle. Yeah, but it is squared. It should be squared. So Q squared equals. This figure has 2 rectangle P plus P times Q, but it has 2. But since it is overlapping, we need to take out Q squared. But 1/4 of this figure area is Q squared. So this is how it can be expressed. So 4Q squared equals to 2PQ minus Q squared. 5Q squared equals to PQ. q, 5q minus 2p equals 0. So if q cannot be 0 because this is the shape, so 5q can be 2p. So p2q, we divide by 2, 5 over 2, so 5 to 2. And number 20, two straight lines have equation p and q, two lines with 3.1. 3,1 is on here and on here, so we plug in to the first equation. 1 equals to 3p plus 4, so p equals to negative 1. So negative 1 multiplied by 1 equals 3q minus 7. So q equals 2. And number 21. Diagram shows a two congruent equilateral triangle, 1, 9, 16. So all has its own, okay. What is area of the inner hexagon? Okay. So let's say when the shape is similar, the ratio of their side, like length side, and the ratio of the area and ratio of the length has some relations. For example, if this and this has the side length A, this has side length B, the ratio of the lengths, like a similarity ratio, is A to B. But when it comes to the area, we can say A squared to B squared. So this is area ratio and this is length ratio. So here, because this is 1, 9, 16 and it or indicate the area, so we can say here x, 3x, this is 4x, which means the larger triangle has 8x, the side length 8x. So we can tell that this shape when we put two equilateral triangles together, there is the shared part, which is here. So we will put them together, we will add them together and take one out from this two-layer part. So larger equilateral triangle, 8x, so it has 64x squared. So here x 16, 1, 16, 9. Yeah, just let me continue like 1, 16. Number 21, there are two congruent equilateral triangles, and also when we overlap them together, there are more smaller equilateral triangles shown, and they have different areas, 1, 9, 16, something like that. You know, when there are two similar shapes, when they have the length ratio A to B, then the area ratio goes to A squared to B squared, and volume ratio goes to A cubed to B cubed. So, for example, if we have two cubes, side length A and side length B, for example. So length, the ratio is A to B. But area, this is A squared, B squared, and we have 6 of them, so this is A squared to B squared. And volume is A, B, B, B. So this is A cubed by B cubed. So on A cubed to B cubed. So this one is very common relationship of this geometrical interpretation in these similar shapes. So for example, if this is one side is x, then we can say this side is 3x and this side is 4x, which means the whole area, the side is 8x. So 64x squared. But anyway, it's a 64 because now the x is not 1, but we can tell the shape. I will do it like this. 1x, 2, 8x. So this is 1 and this is 8x. Then the ratio of area is 1 to 64. So this whole is 64, which means 64, 26, 8, 38. So this is a 38. We can tell the area of here, the overlapped area is a 38. So area of inner hexagon is 38. And when we simplify this, what it can be? Let's make the common denominator on each factor, so like x plus 1, x plus 1, x plus 1 minus 2, x minus 1, x minus 1 plus 2, x plus 1 over x, x minus 1 over x plus 1, x plus 1 over x minus 1. So we can cancel out like this. We have only x plus 1 over x. 23. Semicircle with center O. So this is the one. So 2 and 2 by Pythagorean theorem. This is 2 square root of 2. So let's say 1 is square root of 2. So to find the shaded region, we need to find the area of this semicircle and take out this segment. So let's find the semicircle area. So 2 pi r squared, but this is semicircle, so like this. And minus this one, the sector, like this segment, we can find by subtracting from sector to the triangle. So pi r squared, but this is quarter of the circle, minus 2 and 2. So pi minus 2. So this is 2. And the next one, Sam writes whiteboard positive integer 1 to 6 inclusive, ones each. P additional 5s, Q 7 on the board. Mean of all the numbers on the board is 5.3, smallest possible value of Q. Okay, so 1, 2, 3, 4, 5, 6. And she added more 5s, but P times, and 7s Q times. So we can divide by 6 plus P plus Q because the number of total those numbers are 6 plus P plus Q. This could be 5.3. So 21. 21 plus 5P plus 7Q equals 5.3P plus 5.3Q plus 10.6, 31.8. Now we can say 1.7Q minus 0.3P equals 10.8. This is so 108. So this can be the one. So from here we can find the possible value of Q. So 17Q equals 108 plus 3P. So when we factor with 36 plus P, which means 17Q should be a multiple of 3. So for example, there are only 2 multiple of 3's, but I don't know what is the answer. Let's say if the answer could be 9, 17 times 9, 336 plus P, so 351. Oh, this can be the answer. So this is the smallest possible value of Q. And the next one, Thomas has constant speed, running and walking. Oh, then there is no reason to running. Yeah, down escalator is moving. Run down 15 seconds, walk down in 30 seconds. One day, running speed and walking speed. One day when the escalator was broken, 20 seconds to run down it. Okay. So how long in seconds did it to walk down to the broken escalator? So here, the down escalator, when it is moving, it has its own speed. Let's call the speed S. And let's call the running speed R, walking speed W. So when it goes down and running together, actually it helps to walk down. So the speed can be added together. R plus S. This is a running down. Running down escalator speed, and walking down escalator W plus S. So this is a speed. Again, distance, speed, time. So this takes 15 seconds, and this was 30 seconds. And distance again, same. Distance. And when this escalator was broken, which means there is no speed of escalator itself. So when he goes down, like run down, then he had only his own speed R, and it took 20 seconds. So, and it also still have same distance. So we want to know when this is W, so what is the time, like this. So let's make the distance formula, like speed times time. So R plus S times 15 equals W plus S times 30 equal R times 20. So let's say here 5R equals 15S, so R 3S. So running is faster than escalator itself. Makes sense. So we can put this here. Then S is R over 3. Then W plus R over 3 equals 30. Equals 20R. So 30W plus 10R equals 20R. So 10R equals 30W. R equals 3W. So when he's running, he's 3 times faster than walking. So if it took 20 seconds, because now he's slower, 3 times more slower than walking, so it may take 60 seconds.